Okay, you're good to go. Sorry to interrupt.
Okay, so again, this is a voyaging story talking about how the world's largest oceans came to be settled. Um, let me, but again, in 2014, we took Kokole around the world, and that journey around the world changed my whole perspective how about how this planet came to be settled. And so, actually, the story of how this planet came to be settled by Homo sapiens starts in Africa, starts in Ethiopia. Uh, but Homo sapiens actually show up on this planet. We know that they are living in East Africa about 190,000 years ago. Yeah, I mean about 200,000 years ago. About 190,000 years ago, there's a huge ice age that increases the size of the Sahara desert exponentially, and it cools down the world. But it also puts extreme strain on food resources. So Homo sapiens living in East Africa begin to migrate, and they move all the way to the margins of the tip of South Africa. Here in this area called known as Muscle Bay, there is a series of beach caves, and the story of human development goes back to early Homo sapiens living in caves. They claim that the population of the human population of Homo sapiens on the Earth came from a band of maybe only 400 Homo sapiens. So living in these caves, right? These East African tribal members show up on the coast of South Africa, and they're exploring. And here along the coast of South Africa, we develop all the traits we know as typically human, right? We're different biologically from other species in that we have the largest brain cavities, the largest brain mass of all species on the planet. So here along the coastline, we start to develop the traits that we know as typically human, right? Our language, right? We develop words. We develop finely shaped tools. We develop we decorate our bodies with ochre. But all the time over the 40,000 years that we live along the coastline, we are eating a diet that is high in omega-3 enzymes. And omega-3 is like it's like an additive to the human diet. We're feeding our bodies omega-3 enzymes because we're harvesting the seed of the rich resources that exist there. Things like abalone and mussel and even the carcasses of dead whales. And so we're feeding our bodies this high protein, high omega-3 enzyme diet. And most importantly, here along the coast of South Africa, humans become aquatic. We learn how to adapt our living to the world's oceans. But as the world warms, the Homo sapiens living in South Africa migrate north, right? The planet is already settled by Eurasia is already settled by other species of hominids, right? We have the Homo erectus, which moved across the whole Asian continent, and they end up on the coast of Asia. You have Homo denisovians living here in Siberia, and you have Neanderthals, of course, living in Europe. Also, you have down here in the Flores Strait, you have a very small, demure people on the island of Flores called Homo florensis. But we, Homo sapiens, become the only existing hominid species left on the planet, right? But as we migrate here through Southeast Asia, we are walking to every place that we need to get to, right? They finally walk across these small isthmus of islands here in Indonesia, and they cross the Sunda and Sahu Peninsula. There are waterways, but the largest waterway is only 60 nautical miles. and you can cross those waterways just by tying a crude raft together, logs and fiber, and you don't really need any kind of sophisticated navigation, right? Because you're seeing the landmass ahead, okay? And so they walk basically into Australia, and then about 10,000 years ago, they walk into Australia and the island of Tasmania, and then the Earth warms. It fills in these channels. The channels are now deep water passages, and the pedestrian people that walked there are permanently trapped, right? Because they have no seafaring technology, okay? Then about 10,000 years ago, right? People living in Fujian province here in China, reacting to a new warming of the earth, right? With rising tides, switched their dietary practices. These Fujian province people are basically farmers raising rice, but as the sea levels rise, they change their diets to more marine based, and so they are creating seacraft that allows them to fish offshore, and then they actually eventually get to the island of Taiwan as they keep exploring further and further out to sea, and Taiwan becomes the ancestral homeland for all Pacific Islanders, right? They speak an Austronesian language, and the Austronesian language, before the spread of the European languages, is the largest spread language on the planet, okay? And from Taiwan, right, they start to migrate south and east into the world's oceans, right? And they do this by building seafaring craft, right? It's probably just very rudimentary in the beginning of the exploration, but over time, the craft becomes more and more complex. They also begin to figure out a system of navigation and orientation, right? Just by using their ability to observe the heavens, the stars at night and the sun during the day. And this navigation system is kind of rudimentary at first, but over time it becomes more and more complex. We know the exact pathway that led them out of Taiwan into the Pacific because of the artifacts they left behind. One thing they carried with them were food in these clay pots. And if you know, clay pots, if you drop them, they break, right? These clay pots is called Lapida. It's got very distinct stamped decor on the outside of the vessels, and so they're very easily identifiable. So if you follow the trail of artifacts, it'll lead you back to the island of Taiwan. And so it's the study of archaeology, it's the study of linguistics, it's the study of DNA that build a compelling argument for the peoples of the Pacific having their roots in Taiwan. About 20 years ago, 25 years ago, two researchers wanted to study stone adzes. Stone adzes are made out of basalt, okay? But they're going to study stone adzes from the coral atoll of the Tuamotus. Tuamotus is about 250 miles northeast of Tahiti, right? And the reason why they're studying stone adzes from these coral atolls is because they know, right, basalt doesn't exist on these coral atolls. So they have a collection in the Bishop Museum of 17 stone adzes that Dr. Kenneth Emery in the 1930s collected, and they're going to conduct this research technique called plasma mass spectrometry, by which they melt the stone down to its plasmatic state, and once they get the stone down to its plasmatic state, they can identify the chemical and mineralogical makeup of that stone. And based upon studies, they can identify the exact lava flow that stone came from. So here is the Tuamotu archipelago, and way up here is the island of Napuka. And they took that one small stone adze, and they conducted that research using plasma mass spectrometry, and what they found was that stone adze began its journey up in Hawaii. That is definitive hard science that is indisputable. Okay, and that stone adze, they could identify to the exact lava flow it came from. It came from a lava flow on the island of Kaho'olawe in a quarry close to this place here. The name of this point here on the south side of Kaho'olawe is Keala'ikahiki, which means the road to foreign lands. Okay, so the temporal scale for moving out of Taiwan is about 3000 BC. About 1500 BC, they're in the Philippines. About 1300 BC, they are moving into Micronesia, the Santa Cruz Islands, and they are arriving in Tonga, Samoa, and Fiji by about 900 BC. Okay, so basically about 3,000 years ago. Okay, in Samoa and Tonga and Fiji, this is the cradle of Polynesian culture. Polynesia is defined as a triangle of islands made up of the northernmost point, Hawaii, the southwesternmost point, New Zealand or Aotearoa, and the southeastern corner, which is Rapa Nui or Easter Island. By about AD 700, they're in Tahiti, and really the last places to be settled was Hawaii. By about 1100 years ago, Easter Island by about 1,000 years ago, maybe 900 years ago, and the last place within the Polynesian Triangle to have been settled by Oceanic language speaking people is New Zealand. New Zealand has only been settled by about 800 years. So you can see here that really the islands of the Pacific are the last place on this planet to have been settled by humans. Yeah, but the range of their exploration, right? We know the range of their exploration gets them to South America because the Polynesian sweet potato, yeah, is a South American cultigen. Yeah, it comes from South America. So either a canoe load, well, a raft load of people from Peru or Chile got on board a raft and floated into Polynesia, or actually Polynesian sailors, which is the more likely scenario, sailed all the way to South America, retrieved the sweet potato and a certain kind of bottle gourd and exported it back into Polynesia. Okay, the range of Austronesian language settlement is about 2,300 kilometers. It gets them to the coast of South America at the longitude of Denver, Colorado. But in the west, their range gets them to the island of Madagascar. Madagascar, which is only a few hundred miles off of the coast of Africa, was never settled first by Africans. It was settled by people coming out of Southeast Asia and these islands here. They were the first settlers. Yeah, the Austronesian language people were the first. So 2,200 kilometers, that's the range of the settlement, yeah?
Kalepa, just a quick point for folks. There was a news article just a few weeks ago about an article in Nature that they had traced genetically indigenous people in South America had Polynesian genes.
Yeah,
so there
Polynesian DNA.
Yeah, Polynesian DNA in South America.
Okay. Well, you know, what allowed them to explore, of course, is the canoe, yeah, and their ability to navigate. But despite all the arguments for purposeful settlement, there were still those naysayers that denied that the settlement of Oceania came out of Southeast Asia. And so in the 1970s, the Polynesian Voyaging Society was formed to try to figure out if a purposeful trip of migration was possible. So that's when Hokulea, the deep sea voyaging canoe was constructed. It's a design accurate replica of a voyaging canoe. It's not made out of natural materials. It's made of marine plywood, fiberglass. It's got canvas sails. And in the 70s, they proposed to sail this canoe from Hawaii to Tahiti on an archaeological experiment, right? They're going to recreate this artifact and they're going to sail it, they're going to test it, and they're going to recruit a person skilled in navigation, and this person was Maupiailag. Maupiailag was a Micronesian navigator, right? At that time, there were no longer any living Polynesian navigators, so they had to go outside of the triangle. And the small islands of Micronesia, they still practice this art of Micronesian wayfinding. And so on this island called Sarawak in the Caroline Islands, we recruited this person, Maupiailag, who eventually revives the art of celestial non-instrument navigation here in Hawaii. Okay, so in 1976, they sail Hokulea in May from Honolulu Bay, Maui. They arrive in Tahiti 33 days later. It is a successful experiment in terms of the vessel's performance and the navigation. However, it is as a social experiment, they don't meet the mark. It had been 600 years since we sailed on voyaging canoes, so we really didn't understand the kind of discipline a crew living on board a canoe for 1 month, being out at sea for a whole month, and those pressures just kind of wore the crew down. Mao was so disappointed in the performance of the crew that when he got to Tahiti, he abandoned the project, and so they had to navigate Hokulea back to Hawaii in 1976 with instruments. On board the canoe trip back to Hawaii, being navigated by instruments, was this young man on the left, Nainoa Thompson. And so Nainoa is just a really smart young Hawaiian who filled up these notebooks full of information. And what he proposed to do was he went back to the university and he redirected his studies. He created this liberal studies major, undergraduate major, whereby he was going to re-engineer the art of navigation. And so from 1976 to 1980, he's re-engineering this system, right? And the system is based upon science, right? It's a system that's based upon astronomy, a lot of mathematics, some oceanography, and so he has the elements of his system worked out, but something is really bothering him, and it has to do with the spiritual nature, the discipline that the navigator has to have for staying up for days at a time. And so he talks to his father about the problem, and his dad recommends that he go and find Mao in Micronesia and bring Mao back to Hawaii to help round out his training. And so Nainoa hears that Mao is going to be visiting the island of Saipan on his canoe. So he goes to Saipan. They meet on the beach. Mao apologizes for his early departure in 1976. Nainoa apologizes for the behavior of the crew. And Nainoa asks Mao to come back to Hawaii with him and to round out his training. And I know Mao is uncommittal. He says, just go and I will send you what my decision is. And about a couple of months later, Nainoa gets a call from the customs agent at Honolulu International Airport, and they request that he come to the airport and retrieve one Maupiailag who's waiting there for him. And so with that begins the revival of wayfinding in Hawaii. So we're going to switch the focus now. We're going to talk about navigation and the elements of navigation that are critical to the wayfinding or non-instrument navigation system. Okay, 3 things you need to know is that in navigation is you need a device to navigate your canoe, basically a star compass, right? You need to be able to establish position or track your progress on a course line. And the third thing is you need to find land. And so if we just keep it to those 3 simple things, then it'll be a lot easier for us to understand. So this is Mao's star compass. These stones on the perimeter represent the visual horizon. So any place that the sky touches the land or the sea, or that circle of the horizon around you, that's what's represented here in a circle of 32 stones, right? So in the circle of 32 stones, one side of the circle is the arriving horizon east, another side of the circle is the entering horizon or west, and then you have 2 points, yeah, your celestial poles that the circle of stars spin on, right? If this is east, then the stars rise. They cross the meridian and then they descend, and re-enter the opposite horizon. Okay. So here's our star compass, right? Hikina is the Hawaiian word for east. The word hiki means to arrive. Komohana is the word for west. Komo means to enter. Okay. If I stand with my back towards Hikina, I naturally face west. If I extend my right hand is called akau. It also means north. If I extend my left hand out from my body, my left-hand side is called Hema, that's also south. Okay. The way that stars work, because the houses are defined by the star bodies that live there or reside there. Okay. There are 32 Hawaiian names on a compass. I taught you 4 names, right? But the names, those 4 names are the only 4 names that are different. Yeah. For each quadrant, you have a set of names that mirrors the set of names in the opposite quadrant or in the opposite horizon. So on either side of east, yeah, on the north side, on either side of east, on the south side, right, east and west is the first house we call La. It goes La, Aina, Noyo, Manu, Nalani, Naleo, and Haka. So this quadrant mirrors this quadrant mirrors this quadrant, and they also mirror from across the compass diagonally from quadrant to quadrant. Okay, so if a star rises here in the house we call Aina, it's going to rise in the house we call Aina, and it's going to sit in the same hemisphere in the same house that it rose in. Only thing on the opposite side of the compass. If here a star rises in the house we call Noyo, if you know where a star is rising, you know where it's setting. Yeah? If it rises in Noyo, it's going to set in Noyo, right? So celestial bodies move in parallel tracks from one horizon to the next, right? They climb out of the horizon, they cross the meridian, and then they creep back down into the western horizon. But this is an oceanic compass, and so we need to integrate the winds and the waves or the swells that move from one quadrant to the next, right? So if you know where the swell or the wind is coming from, let's say the wind or the swell is coming from the south, called Manu. In the quadrant we call Kola. It's going to move through the center of the compass where you're standing on the canoe, and it's going to exit the opposite house, yeah, of the same name, yeah, but only thing in the opposite quadrant. Okay, and the way we teach the stars is we have this chant that we practice. It's called E Ohi Ohi Inapono. So I, as a leader, call out to my students, E Ohi Ohi Inapono, which means gather up your implements, right? And then my voyagers, right, is going to repeat after me: a baler, a bone, a fishhook, a kite, yeah. And we're all going to say, "Uolako ka ipu oka ho'okele." A container of knowledge is provision. Again, E Ohi Ohi Inapono. Voyagers, gather up your possessions. He ka, he iwi, he makau, he lupe. A baler, a bone, a fishhook, a kite. Uolako ka ipu oka ho'okele. The guard of the navigator is provision. And so what those represent are the 4 star families. And basically, we've taken the dome of the night sky and we've divided up into 4 different sections, right? The first section is called Keka or Makali, which is the baler of Makali. A baler is a scoop that you scoop water out of the bottom of the canoe. The second is Ka'iwi Kuamo'o, which is the bone. The Kuamo'o is the backbone. The third is Manayakalani, which is the fishhook. The fishhook is made up of Scorpio. And the fourth is Kalupi, or the kite. Yeah, the kite is made up of the great square of Pegasus, right? Again, these star lines run from north to south across the sky, and they take up 1/4 of the night sky. So the first star line is the Ka, or the baler of Makali, and it is made up of these stars here: Capella, Gemini, the twins, Procyon, the little dog, or Sirius and big dog, and then it terminates down here in the south in the star we call Canopus. This is the handle of the Baylor. This is the scoop of the Baylor, and it is carrying up all these bright stars in it, right? Orion's belt. Yeah. If you take a line through the 3 stars in Orion's belt, it leads you to Aldebaran in Taurus the Bull, and then the Pleiades. Okay, the EV Como, the backbone. It's North Star to Southern Cross. Yeah, you look for one bright constellation. In this case, you're looking for the Big Dipper. Big Dipper points to Polaris, right? You come off the tail of the Big Dipper, follow it around to Arcturus, over to Spica, and then these 4 stars, which is Corvus the Crow. Okay, you take a line through the middle of Corvus the Crow, and it points here to the Southern Cross, and the Southern Cross upright points to south. Okay, the third is Manayakalani, the chiefly fishing line. We see the summer triangle, yeah, as the spool of fishing line, and it's tied to the hook here, which is Scorpio, yeah, and then it's fishing after the great celestial jack, which is Sagittarius. Okay, again, here's the summer triangle, yeah. It is made up of Deneb, Vega, and Altair, and here is Scorpio. And right here is Sagittarius, and the neat thing about Sagittarius is that, so this is the fish hook, yeah. This is Sagittarius. It looks kind of like a teapot. Here's the top of the teapot. Here's the spout, and here's the handle, right? The celestial teapot. But in the center of the spout, yeah, is the center of the Milky Way galaxy, right? And then the last star line is Calupio Cavello, the kite of Cavello, and it's named after chiefs. The box of Cavello, yeah. The 2 edges of the box of Cavello passes through the meridian at the same time, so you can always draw a line through the edges of the box, and it'll always point you towards celestial north or celestial south. Celestial north or celestial south. Oh yeah, that's our star lesson. Again, our navigation is very visual. Anything you can see with your eyes, you can use to navigate. Again, we like to use our hands as the only tool that we use for measurement. This is Nainoa figuring out the altitude of the sun, but we actually calibrate our hand so that our hand is calibrated precisely by degrees of altitude off the horizon. We can figure out our exact latitude based upon the height of certain stars as it is culminating or passing through meridian. At meridian, it is at its highest point. We measure a particular star, and we can compute our latitude. Here's an example of a star measurement we use for establishing the latitude of Hawaii. This is the Southern Cross. It's upright. Okay, the distance between the top star and the bottom star is 6 degrees at the latitude of Hawaii. When you leave Tahiti, the Southern Cross is some 40-something degrees above the horizon. Okay, but as you approach every night at sea, the Southern Cross is getting lower and lower. When you can get the top star and the bottom star equal to the horizon, you're at the latitude of Hawaii. So here we are, right? We measure 6 degrees between Gay-Crox and A-Crox, the top star and the bottom star, and we measure 6 degrees between A-Crox, or the bottom of the Southern Cross, and the horizon. And when we get that relationship in the night sky measured accurately, we know we're at the latitude of Hawaii. So we employ a system called upwind sailing, whereby we want to be upwind of the islands. And so at this point, we would just turn our canoe downwind, and it would lead us to land. There are archaeoastronomy sites in Hawaii. This is a sighting wall on the south side of Maui, and so this is used to figure out the celestial meridian. Here's an example of how this is used to establish the celestial meridian. This is the Southern Cross upright and above the notch in the wall. Again, so that's how you use stars in our orientation device. To locate position on a course line, we use waves passing along 2 points on the canoe. We establish we measure these distances, and we establish this algebraic formula. And basically, it's based upon the number 25. So if a wave was to break here from the front cross beach, you would count how many seconds it takes for that wave to reach the back of the canoe, right? And you would divide how many seconds into the number 25. And based upon that algebraic formula, you would be able to compute your speed. So let's say I count here 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, right? So 5 divided to 25 is 5. So I'm going 5 knots, right? If I can average 5 knots over 12 hours, right, sunrise to sunset, I've gone 60 miles, right? If I can do that for 24 hours, I've gone 120 miles. And so I know I'm 120 nautical miles into my journey. Right? The way it would work traditionally on a canoe would be in prehistoric times is that people migrating out of Taiwan would count how many moon nights it took them to go between 2 islands. And then once they had that information, they would always know that to go from island A to island B maybe took them 6 moon nights. And so after 6 moon nights of sailing between these 2 islands, the island should emerge on the horizon. If it doesn't emerge on the horizon, they're either going too slow or they've gone too fast and they pass the island. And so they've got to re-strategize land finding protocol. And the last thing is finding land, right? I said the 3 things was orientation device, fixing position, and then finding land. In this case, as you're approaching the islands in the South Pacific, they're very low and they have a lot of these white turns on it. When you see the white turn, you know you're 72 hours from land. The height of the stars will tell you when you're getting close, but the white turn is a definite sign that you're approaching land. And so in the mornings, those white turns will fly out from the island. In the afternoon, they'll fly back, and you just take a bead on their return flight path. And basically, right, it should lead you to land. Now I'm going to just transition. I'm going to talk about a particular voyage. Again, this is the Polynesian Triangle, and the voyage I'm going to talk about is our last hardest leg of all, which was navigating the canoe to Easter Island. The reason why it was so difficult, and the reason why we didn't want to do it is because the island is remote. It is 1,600 miles from the last island to Easter Island, and the sail is directly upwind, right? So the only way you can get up there is you're gonna have to be able to tack back and forth. Okay. The island is small. It's only 15 miles long and it's 7.5 miles wide. Right. So that's why we kept Rapa Nui off as a place to visit until we're super confident that we developed the skill by which we could navigate the canoe to go actually attempt this experiment at finding our small remote island. Okay, and so this is the sail strategy, right? This is the last island we're leaving, which is called Mangareva, and we're just going to execute a series of tacks upwind, and we estimate, right? And in the very end, about 200 miles away from the island, we're going to execute these very small tacks, and on one of these tacks, we're going to cross the island chain. Okay, and so if we estimated 40 plus days to complete this trip. However, we're also smart. Yeah, we did excellent climatological studies, and we knew the winds would go into a reversal phase, and we planned our departure for when the likely reversal trades would go. And so this is the actual course. Yeah, the winds shifted. Instead of coming out of the east, it came out of the north. And so you can see our sail track is actually almost straight to Rapa Nui, right? And so people thought we were cheating. Actually, they thought we were cheating, but it was just being smart about evaluating the climatology and then picking the right time to sail. I wouldn't want to do this trip again, though. So Rapa Nui is known for its great big stone statues called moai. Again, I got on board the canoe in the Marquesas, and then we sailed down here to Mangareva, and then along the way to Rapa Nui, we stopped at this pretty historic island, Pitcairn, where all islanders, almost 75% of the islanders, all have the same last name. They take the last name from the original ancestor, Fletcher Christian. This was a very tough trip because of the navigation and the remoteness of Rapa Nui. And so the crew there was no levity on board this crew. We had to be super serious. It was a very, it was the most disciplined I have ever been on the canoe. But after about 19 days of sailing due straight east, and every morning we just get up expecting the wind to change. The wind was still coming out of the north, and so we say mahalo kia kua, say our prayers, and hope for another day of winds coming out of the north. Our crew members picked up a black cone on the horizon, and that was Rapa Nui. And this is me greeting the first Rapa Nui on board the canoe. All the stone statues on the island comes from one single crater, Wanarorako. This is a sample of what happened to the culture on the island. There was great upheaval, and so all the stone statues was toppled over. I think it was the first re-erection of these stone statues happened in 1960. There are several places now with stone statues that are erect or standing. But when the stone statues was toppled, it was replaced by the orongo call. The orongo is basically the call of the bird, and each tribe would have a member enter this competition, and they would go and live in these stone houses on this point of land here. And all around this place are these stone petroglyphs of birds, because what happens is the birds would annually migrate to this island and they would nest. And so when the birds showed up on this island, the competitors would scramble down this 2,000-foot cliff, and they would swim across to this island, and they would wait for the first egg to be laid. And then the first person to bring the egg back to land and present it to the chief became the birdman. And so the birdman's annual winnings was that they control all food resources on the island. And then in 2013, we participated in this worldwide voyage where we went around the world. 2013, we sailed around Hawaii. 2014, we went all the way down to New Zealand. 2015, we went to South Africa. 2016, we went across to Brazil and all the way up the Hudson River to Montreal. And in 2017, we re-entered the Pacific and we came back home. Again, on this trip, we traveled 60 nautical miles. We visited 150 ports. We visited 23 nations. Took us guys 3 years to complete. Again, our mission was an environmental. On this planet, there is no green without the blue of the ocean. The Earth makes up 70% of the geographical area of the planet. Without the blue of the ocean, there is no green on this planet. The Earth, the world's oceans regulate climate change, and they are the #1 incubator for oxygen. And so we went on this global mission to understand the world's oceans. Two things you needed to do to conduct a mission such as an attempt to go around the world. You need to understand tropical cyclones. And the way to avoid tropical cyclones is whatever hemisphere you're sailing in, you always sail during the winter season, because what generates a tropical cyclone is heat, right? So if you're staying out of the hot seasons, then you're basically free. And then this was another danger that we had to overcome. These little balloons represent incidents of piracy, annual incidents of piracy. So we chose a route that took us away from pirates around South Africa.
"7,000 years ago, the first really oceanic people came out of China, and it came out of Taiwan. Then you get to Polynesia, this oceanic country bounded by Hawaii in the north and New Zealand in the southwest, and Rapa Nui in the east. 10 million square miles, bigger than Russia. And it was discovered by these extraordinary people. They were really the astronauts of our ancestors. They were the greatest explorers on the face of the earth.
You know, our ancestors not were only just great navigators, they were great stewards of these islands. The time that the first Europeans came, the journals of Captain Cook talked about, you know, large populations, maybe 800,000. That's the median. It could be even higher. It's approaching maybe the numbers of people that are living on Hawaii today. They figured it out, how to live well on these islands, and I think that is the challenge of the time for planet Earth and all of humanity. It's to figure that out. How are you going to do that? Hokulea is pulling us into a direction of asking the question, are you going to be responsible and are you going to take action? Are you going to do something with what you have? You got a voyaging canoe. Hokulea, to us, to go around the world, has this enormous potential to go to 40, 50 countries on the planet, to be with the great navigators on Earth. And I'm not talking about those in canoes. I'm talking about those who are doing things to give kindness and compassion to the Earth and those who live on it. Those navigators. We're not going to change the world, but we're going to go and build a network of people around the Earth who are going to change it. And our job is to help them be successful. We're going to go around the world, and I'm willing to take the risk to do it, because the greater risk is to not act. The greater risk is to be apathetic. The greater risk is to remain ignorant, and the greater risk is not to take action.
In 3 years, Hokulea traveled more than 40,000 nautical miles, stopping at over 100 ports of call across 27 nations. Her cruise connected with some of the world's greatest influencers and engaged with those creating innovative solutions to protect our island Earth.
In my humble opinion, the success of the worldwide voyage was really building relationships from strangers from around the world. I watched our crew members. Every single place we went to, everybody that they met was treated with respect and with decency. That was the key and the core to the success of the voyage. That is why we have strangers turn into relationships, and relationships are now coming together as a movement around the same thing, caring values. Mālama honua.
Hokulea returned safely to Hawaii, welcomed by a network of people from around the world who have been inspired by her voyage.
Eyo Hokulea.
What I'm really thinking about more and more now, I'm just imagining, just imagine where Hawaii is going to be in 20 years. I mean, all these kids coming up, they're just going to be extraordinary leaders. What we need to do is stay on course, keep going, move inspiration into action, and really help move the movement of kindness around the Earth so that it starts to have real impact. And you need to do that through your core relationship and build others. And get Mālama honua off the canoe into the communities. People need to know about what people are doing in classrooms, in our universities, in their backyards, in a coral reef, in the watershed, in our lo'i, in our fish ponds. I mean, we need to just capture the stories. It's going to start to celebrate all these people that people don't know. This is the canoe, and it's our communities are the navigators. I think we're on course, but the voyage ain't over. It's that simple.
So, Mike, I've come to the end of my presentation, so I'm gonna stop share, and then I will turn it back to you for maybe some Q&A.
Sounds great. That was fantastic. Absolutely marvelous. Thank you so much for sharing. We'll take questions. Given the size of the group, can people raise their hand feature in Zoom, and then I'll call on you? I will start. Let me ask, is there some estimate or guess even how many voyages must have occurred for the Polynesians to have found Hawaii in the first place? I mean, little tiny strip of the ocean. Yeah, how many trials?
That's a great question. Yeah, there's no record of how many failed voyages there were, right? I have to assume that in an attempt of humans crossing the oceans and finding new islands, that there must have been a few voyages that never made it, but we don't know that record. However, we know that they got to every single inhabitable island within the world oceans. They were, by the time they got to figuring out how to explore, they were true professionals at that art. They were well prepared. They were excellent navigators, and they could survive on a open ocean going canoe a lot easier than we humans today could.
I have a question from Thomas. Thomas, go ahead.
Yes, I hadn't heard about the trip to Rapa Nui and the sort of terror that you expressed. Now, would you say an analogy would be that our collective Rapa Nui is what we need to do with folks like Greta and the Hokulea.com and all of that to save the planet from this carbon dioxide? Is that our Rapa Nui?
Yeah, I guess that's one way to look at it. It was and I read a book by this UH archaeologist. I forget his name. It's pretty famous, but it's a book entitled "Statues That Walk," right? And so
that's Terry Hunt.
Yeah, Terry Hunt, and he claims that the degradation to the environment was very slow. It was ongoing, but it's not like you're gonna wake up one morning and say, "What are we doing to this planet?" But there was clearly it was a slow decline to the environment. So I'm just kind of sharing that as an idea, is that yeah, we need to be more observant about the changes we are bringing to the planet today. It's a lot more visible and a lot more seeable than probably the natives were aware of on Rapa Nui. But thank you for your question.
Other questions or questions from the students? We have quite a few students.
I have a question. I was just wondering what's next and what's the mission going forward?
Well, once the pandemic clears, they have an even bolder mission that's a lot, in terms of distance travel, will be a lot further than going around the world, and that's to travel around the Pacific Rim, starting in Alaska and sailing all the way down to the North American, South American continent, coming across, re-entering Polynesia, sailing across to New Zealand and Australia, coming up through Indonesia and China, and then circling back over the top the Aleutian Island chain and then back into Alaska.
Esther had a question.
Yeah, it was a follow-up on that, and it's how far north have you actually sailed if you're talking about the Aleutian Islands?
We've sailed as far as either Juneau or Anchorage.
Wow.
So, yeah, I mean, you know, and I'm not sure how far. I guess Montreal isn't as high in latitude as Anchorage, but yeah, we did go up the Hudson River to a little bit past Montreal before we came back down.
But aren't the currents and
yeah,
you know, in terms of familiarity very different?
It's extremely different. You know, again, I said we traveled there. We didn't sail there. You need auxiliary power to travel up rivers, and so we basically towed the canoe to all these different parts, and because of safety reasons too. I mean, you can't navigate without instruments in the coastal waterways of the East Coast. It's impossible. I mean, the fog is so thick up there, you cannot see from the back of the canoe to the front of the canoe, and so it's really cool and really beautiful, but it's super dangerous. And so we use an escort boat to get us around in those places where it is not feasible to navigate without instruments, places where we need auxiliary power. But whenever we're out on the open ocean, crossing the Atlantic or crossing the Pacific, we are utilizing wind power and we are utilizing celestial star navigation to navigate the canoe.
I think Mackenzie was next, and then maybe I think Bo has a question after her.
Hi, that was a really great talk. I was just wondering, you had mentioned how the Southern Cross was used to, once it was at a certain degree above the horizon, you knew you were at the latitude of Hawaii. I was just wondering if there were any other constellations or stars that were specifically used on navigation to, you know, as a mark.
You know, again, we figure out the sail plan, and once that's all strategized, then we look at the night sky figure out how are we going to do this, how are we going to guide the canoe. The Southern Cross is the most, for finding Hawaii Island, the Southern Cross is the best. I don't know of any other clue. For finding Tahiti, for measuring the latitude, you take the two stars in the Little Dipper, the bucket, Furcat and Kochab, and it's basically when Furcat and Kochab, right, the two stars in the Little Dipper are above or on the meridian, right? They're 16 and 18 degrees above the North Pole. So when you're on the equator, they're 16 and 18 degrees above the horizon when you're at the equator. Tahiti's latitude is basically 17 degrees south. So you basically sail south to where you lose those two stars. And when you lose those two stars from being visually able to see it, you're at the latitude of Tahiti. You should be seeing clues for land way before that, though. So that this is the tools that astronomy provided us when Nainoa went back to school to go study, right? Again, we're using all whatever resources are appropriate for us guys to develop this wayfinding or non-instrument navigation system.
I hope all my technique students are remembering the problems on the first homework set, which were not so different than what he's describing. Bo, you had a question?
Oh, yes. This is a follow-up to Mike's question, namely, is anything known about how big the crews were that did the first explorations going to Hawaii? And in practical terms, how much food can be packed into a canoe? In other words, could a crew survive for 2 months, 3 months, 4 months? At what point would they really need to find land to survive?
Okay, so that's because I think the limit would be about 30 days at sea. And again, this is packing dry goods and trying to keep the dry goods edible throughout the trip. There were great fishermen. So they were true survivalists, right? The biggest question would be water, right? But they were hardy people, but they would probably take husked coconuts, so just the coconuts in the shell for drinking. I would think the size of the crew, they say that the population of Hawaii was about 400,000. I think it was more like 250,000 when Captain Cook arrived. But that density of a population could have been started by a canoe load of maybe 10 people. That's all you really need. And so, yeah. You know, on board Hokulea, we really don't like to take a lot of crew members because it's more, it's depending upon the length of the trip, then you got to pack more food. And we just like going with small crews. I think 15 is the average size crew. 12 is like a small crew. And on board Hokulea, we have, it's a modern sailing vessel, so we have carrying capacity. We can carry 2 or 3 months worth of food on board the canoe. And of course, if we're fishing on the open ocean, and the key to fishing is speed of vessel. If you can average 7 knots, and you just got a very novice fisherman, you're gonna catch fish, guaranteed. And so you could feed a canoe load of voyagers without even touching your brought along food stores. You could just consume fish and rice every day.
That sounds
All
good.
right, thanks.
Other questions? I had a follow-up question. You mentioned, you know, the stresses and the discipline needed to undergo these voyages. I was wondering, you know, what sort of training or preparation you folks go through to make sure everybody is prepared for such a trip?
You know, we really don't go through any kind of training, except that we do work together, right? We work through the dry dock process. You go on training cruises, and in those training cruises, you're getting to know each other. You're getting to talk about the mission, about the purpose of the trip, and you know, the majority of our crew members come from the islands, and there's some kind of a island culture that permeates the deck of the canoe. And so I've had for the 3 years I sailed around the world, I had like, I'd say 99.5% of my crew members, I always invite them back. They were like the best supporters. They realized the mission. They supported us really, really well. So I was lucky in that. But I had excellent crew members, and part of that comes from the leadership. You gotta be able to build relationships among the crew and among the people you see. And that was the shortcomings of 1976. They really didn't talk about mission. They really didn't talk about what the trip was actually going to accomplish, and they didn't work together.
You have any other questions for Kalepa? Okay, if not, we're at time or slightly over. I want to thank Kalepa again for taking the time to share this with us. It was an absolutely marvelous presentation. And of course, thanks again for your support for Astronomy and Mauna Kea. That's it for today. Thanks, folks.
Hey, see you guys.
Professor, should we stay on here to talk with you or later?